So in this video, we're going to start introducing a few initial circle theorems. Now, a few of these will have some carryover to what we were talking about with congruence in the past, as well as some other parts in measurement that we've talked about, particularly in regards to arc length, which we will revisit pretty soon. Now, if we remember from when we did measurements that to find the length of an arc, it was the same formula, and as an arc length got bigger, it corresponded to a larger angle. So our first theorem here is that equal arcs subtend equal angles at the center of a circle. So what this means is that if the arc AB and EF are the same, the corresponding angles must also be the same size. So because AB, the arc AB, is equal to the arc EF, the angle AOB and angle EOF are exactly the same. Now, with this in mind, we can, when given that two arcs are the same, we can find the value of an unknown angle. So here we're given that arc AB equals arc EF. So we can say X equals to 68 degrees because the angles will be the same. Now with geometry, we always want to give a reason. So we're going to say equal arcs subtend equal angles at the center. So once we introduce a circle theorem, we can use it in our reasoning later on. Now, another thing we're told is that equal angles at the center of a circle stand on equal arcs. So what that means is when these angles are the same, let's call them both theta, they're exactly the same, we can conclude that arc AB and arc EF are equal. So for here, we're going to write arc AB equals arc EF. So the reason we give is that equal angles at the center stand on equal arcs. Okay, so using that, once again, we can make a similar conclusion to what we did previously. So because we know that the angles here are the same, AB, the arc length AB, must be the same as the arc length EF. So we can say here AB, or let's say arc AB, to specify that we're talking about an arc here and not a chord. So arc AB equals to 16 centimeters. And we are going to give that same reason as before. So we're going to say equal arcs subtend equal angles at the center. Okay, now as we move on, as we introduce some of these circle theorems, some of these will require proofs. So we're going to go over some of the sort of formal proof writing that we have been introducing before, particularly when we talk about congruent triangles. And there's a lot of carryover to the circle theorems with those proofs that we have done in the past. So here, our theorem is that equal chords subtend equal angles at the center of a circle. So we've been told that AB is equal to EF, so that these chords are the same. And we want to prove that AOB equals angle EOF. Now, remember, since we're given these arcs, we can draw these lines across from the center to make two triangles. Now, if we can prove that the triangles are congruent, we can then make a statement about these two angles. So what we're going to say, with all of our congruent triangle proofs, we have to first introduce our triangles in triangle AOB and triangle EOF. We can say that AB equals EF, and this is given. Anytime it tells you it in the question, we can just give that as a reason and say that it is given. So we can also say here that AO, side AO, equals side EO, And this is equal radii, because remember, we've drawn a couple of radii from the center out to the circumference, and these will be equal. This is a feature of all circles. And we can also say that BO is equal to FO. The reason being that these are equal radii also. Now that we have that, we can therefore now say that they're congruent. So we can say triangle AOB is congruent to triangle EOF. And the reason is we've used side, side, side. Now, since we know that these are congruent, that means that the corresponding angles in the congruent triangles are equal. Now, since side AB and side EF are corresponding sides, we can say the angles opposite them, these ones that I've drawn up at the center, this one and this one, we can say those two are the same now. So we can now say, therefore, that's a pretty bad therefore, let's try that again. Therefore, angle AOB equals to angle EOF. And we can say, because remember we have to give a reason when we talk about proofs, we can say corresponding angles in congruent triangles are equal. Cool. Okay, so now we're getting used to sort of doing the proofs as well as just finding the unknowns. So a lot of these, the structure is going to be, we're going to prove the theorem, then we're going to use the theorem. So as you can see here, we're given that AB equals to EF. So it's saying to find the value of X. Now, we can just say, because of the theorem we just proved, that X equals to 68 degrees, and we put our reason. So we know that equal chords subtend equal angles at the center. Okay, let's move on. Now, we're given another one. So we are told the circle theorem we want to prove is, we're told that equal angles at the center of a circle, why isn't this highlighting? That's okay. Equal angles at the center of a circle stand on equal chords. So we're given that angle AOB equals angle EOF, and we want to prove that AB equals to EF. So we're going to introduce our triangles again. So in triangle AOB and triangle EOF, we know that AO equals to EO. These are equal radii, we know that. We also know that BO equals FO. These are equal radii also. And we also know that angle AOB equals angle EOF. And the reason here is that it's given to us. Now, we have two sides and an included angle. So we can say, therefore, triangle AOB is congruent to triangle EOF. And the reason is side, angle, side. Now that we know that they're congruent, we can make a concluding statement. We can say that AB equals to EF. And the reason is that corresponding sides in congruent triangles are equal. Okay, now that we've proved the theorem, we're going to calculate an unknown. So it's saying the chord EF is 16 centimeters. So this guy here is 16 centimeters. It's saying to find the length of the chord AB. Well, we know from our theorem before that AB has to equal 16 centimeters. And we're going to put our reason in brackets. We can say equal angles at the center subtend equal chords. Okay, almost there for this video. We've got a couple more. Now, here we're just using another theorem here. So we're told that equal chords subtend equal angles on a circle. Now, we're told that this side, this chord, AB, not the chord, the chord ABEF is 6 centimeters. We want to find the value of X. So we can say that X equals 6 centimeters. The reason, we know that equal chords subtend equal arcs on a circle. Okay. Making our way through. Now, we're told that AB equals to 4 centimeters and we want to find the length of EF. So what we're going to do, using that theorem, we can say that EF equals to 4 centimeters. And the reason is that equal arcs subtend equal chords on a circle. Alrighty, now we'll go one more proof and then we'll wrap it up for this video. We're told, circle theorem, that a line through the center of a circle perpendicular to a chord bisects the chord. Now, just a recap on what the word bisect means, that when it cuts it, it makes these two sides equal, or these two line segments equal. So we're told that here OP, for example, is perpendicular to the chord AB, and it bisects it. So we essentially want to prove that AP is equal to BP. Now we're going to do this by, you can see here the dotted lines, by drawing from the center of the circle out to these points A and B. We essentially make two triangles. Now it's perpendicular, so we can see we've labeled this as 90 degrees. Now, to write up our proof, we're going to introduce our two triangles. So we can say in triangle APO and BPO, we can say that angle APO, so this guy here that's already labeled, equals angle BPO. And the reason that is that OP is perpendicular to AB. So if it's perpendicular, both those angles must be 90 degrees and they're angles on a straight line. So if one of them's 90, the other one has to add up with it to give 180. So then BPO must also be 90 degrees. We also know that OP is common. So it's a side that's common to both triangles. And we also know that OA is equal to OB. And the reason is these have equal radii. Remember when I said before that a lot of these have to do with using the radius. That's going to be a very sort of common thing we're going to be doing here. Now, we have 3 bits of information, so we can make a concluding statement. Therefore, triangle APO is congruent to triangle BPO. And the reason is RHS, because we have a right angle, we have a hypotenuse that's the same, and a side that's the same. So because we know that these two triangles are congruent, we can therefore make a statement about AP and BP. So we can say, therefore, AP equals BP. And the reason is similar one we've been using this whole time. So corresponding sides in congruent triangles are equal. Okay, now we've proved the theorem and now we're just going to use this to find the length of AP. So we know that BP is 8 centimeters, so we're going to say, we can say that AP is also going to be 8 centimeters. So we can say AP equals 8 centimeters. And our reason is the theorem that we just proved. So we're going to write the line through center, perpendicular to the chord AB, bisects the chord. Remember, when it bisects it, it means that it cuts it so that AP is equal to BP. Now, we'll end it here. We'll finish off this part on arcs and chords in the next video. But thank you so much for joining me, and I'll catch you.